Here we are on cylinders and cones. The first video is going to be on cylinders, the second one on cones. For cylinders, if we simply think about them as circle versions of prisms, where the bases are circles, it helps us to understand where the formulas come from. And so when I picture a cylinder, I picture a container of Quaker oatmeals. A right cylinder is similar to a right prism. The segment that joins the centers of the circular bases is an altitude. So I'll write it just below here because of the space. Its height or its length, it measures height, and its length is the height of the cylinder, which we'll abbreviate as h. The radius of the cylinder is the same as the radius of the base. And the lateral area, when we describe lateral area for a prism, it's all the rectangles summed together on the sides of a prism. So in this case, if we think about a cylinder, if you take a sheet of paper and you roll it up into, think of a toilet paper roll, that is a cylinder in shape. And if you were to unfold it, you get one giant rectangle. So let's go ahead and draw that out. So if you were to roll up a sheet of paper, think of it rolled up this way, you get a cylinder. And if we unfold that, we get a giant rectangle. So when we think about lateral area, we want to think about, well, how do I calculate the area that is used to wrap around that cylinder? And so if we think about the top dimension here, if we think about what that actually is of a cylinder, it's the circumference of the base. So let's go ahead and call that C here. Now enlarge it here. That's the circumference of the base, whereas this other unit of measure is the height. So you have the circumference and the height. And if we replace that within our formula for the area of a rectangle, since this is lateral area, we would say the lateral area formula comes from the circumference times the height. And if we replace the circumference formula with what we learned from the last chapter, that simply is just 2 pi r, or pi times d, and then we times it by height. So the lateral area for a cylinder is 2 pi r times the height of the cylinder. Now the total area, think total area, surface area, enough to cover both the side of the cylinder and the top and the bottom, which are circles. We would have to add the bases. So for the total area, which I believe there isn't a spot there, so we're going to write it in a different color to the right of that. Total area is that of the lateral area plus the two bases. So if we want to keep it nice and simple like that, we can leave it like that, or replace specific values for lateral areas, a formula for lateral area. In this case, lateral area being 2 pi RH for a cylinder. If I replace that, I have 2 pi RH plus 2 times the area of the base. And since those are circles, 2 pi r squared. And so I will highlight both formulas. This is what we commonly think of when we think of lateral area, and this is what we commonly think of when we think of total area of a cylinder. The volume of a cylinder equals the area of the base times the height of the prism. So same exact thing as a prism. So I'm going to go ahead and write that out, and then we'll do the necessary replacement from there. So if the volume is, from what we think about a prism, is the area of the base times the height, the base in this case is pi r squared, and then the height is h. And this is because it's the base is a circle. So we have pi r squared h is the volume formula. So we're going to do a few examples on the next page on cylinders. So on the next page, you'll see that on part A, you're given the radius and the height, calculate lateral area, total area, and volume. So for the lateral area, if we think about the lateral area from above as the circumference times the height, or 2 pi RH, let's write out the formula and do our substitution. We have here and we're also going to keep in mind, with just like when we were dealing with circles, everything's going to be in terms of pi. So if I do my calculation above here, just because there's more space here, R is 5, and this is for question A. 2 pi times 5 times 10. So again, commutative property, 2 times 5 times 10 is 10 times 10, or 100 pi. For total area, we're going to take what we got for lateral area and then add the area of the two bases. So if you want to simply think of it as lateral area plus the area of the two bases, you can think of it as 100 pi, which we got for lateral area, plus 2 times the area of the circle, and the circle would be pi r squared. So pi and then 5 squared. So I always do the squaring first because that's exponents before I multiply according to PEMDAS. So this would be 25 times 2 is 50. So 50 pi plus 100 pi, we can add together combined to be 150 pi. And let me just make sure I highlight this so you guys see the answers: 100 pi, 150 pi. And finally, we got to volume, which again is base times height. Since cylinders are circle versions of prisms, it's pi r squared times h. So pi r squared, we'll substitute r in, 5 squared times the height, which is 10. So 10 times 25, we get 250 pi. Sorry, this is also squeezed in here. Can zoom in for you guys to see the solutions here, 250 pi. And finally, we get to one with a radius that is a radical. So that just simply means, remembering all our radical rules here. So let's substitute this into 2 pi rh. If we do so, we have 2 pi, r happens to be radical 7, and h happens to be 3. So the numbers that are not inside radicals, we can multiply together. Keep the pi as is, so that's going to give us 6 pi times radical 7 is the lateral area. And then for total area, if we think about it as it's the area of the sides, which is my lateral area, plus the area of two bases, which happens to be circles. So pi, and then r squared happens to be radical 7 quantity squared. Remember that when you square your radical 7, which actually should just be we should just square the radical 7. If we square radical 7, it'll undo the square root, so we're left with just 7 inside. So rad 7 times rad 7 is just 7. 7 times 2 is 14 pi. So our final total area is 6 pi rad 7 plus 14 pi. And we can box our answer here or highlight. That's lateral area, total area. And our volume calculation would be pi, substitute in r, squared times height, which in this case is 3. Again, squaring radical 7, squaring the radical will undo the radical, so you're left with just 7. 7 times 3 is 21 pi. So 21 pi is my volume for that cylinder. So let's see what happens when we're given volume and we have to work backwards. I believe there's a pi missing from here, so in blue, I'm going to write 192 pi. So anytime you guys are given something where you have to solve back to something that should have been given to us at the start, the radius wasn't given to us and we want to solve for that, let's go ahead and work backwards to figure what that is. So 192 pi is my volume. Well, what is the formula for volume? The formula for volume was base times height, and my base was that of a circle, so pi r squared times h. Now, we'll notice that there's a pi on both sides, so essentially you can divide out the pi, and the pi will be divided on both sides, canceled out, and so we're left with 192 equals r squared times h. Since that's two variables, we want to go back and see what it is that we had. Well, we had what the height was, and that's 12, so we can substitute 12 in on both sides. 192 equals 12 r squared. And so if I divide both sides by 12, I should get 16, and let me just verify that. So let me pull up my calculator and see that 192 divided by 12 is 16. So r squared is 16, and to undo squaring, we take the square root of both sides, which gives us a value for the radius of 4. So again, working with the information we were given, we got that the radius is equal to 4. Now that's going to allow me to figure out what lateral area is and total area, both of which were dependent on the radius. So now switching back to finding lateral area, it's 2 pi r times h. So we have 2 pi, the radius is 4, and the height is 12. So we end up with 2 times 4, which is 8, times 12 is 96, so 96 pi. And then total area would be 96 pi, and then we're going to add 2 pi r squared. So 2 pi, and then r squared would be 4 squared. So we get 8 times 2, which is, or sorry, 4 squared is 8 times 2, 4 squared is 16, times 2 is 32. So we have 96 pi plus 32 pi. And then if we add the two together, we should get 128 pi.